As I record this episode, we're still experiencing rather poor weather for observing and imaging. But we've had just a few clearish nights, so maybe things are starting to look up, so to speak. In this episode, we'll see that for the most part, the planet show has shifted from the evening to the morning skies. We'll discuss one of the most reliable meteor showers and then explore several of the best Messier objects that are in the band of the Milky Way and are well placed for observing on August evenings. Please like and subscribe if you're watching this on YouTube. The more subscribers we get, the more that we show up in YouTube searches, and that means more people can learn about the wonders of the night sky. I'd really appreciate it if you could do that. Thanks. Well, we have a lot to cover, so let's get to it. Welcome to the AstroGuy Podcast. I'm not an expert. I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem. Seize the night. Welcome to the AstroGuy Podcast. I'm your host, Wayne Zuhl. This month, we'll actually start with the moon, which will be full on August 1st. It will also be a supermoon. A supermoon occurs when the moon is nearest to the Earth when it's full. Unlike what you'll sometimes see on social media, the moon will not appear much larger than normal. In reality, it only appears about 5% larger than normal, so it's very hard to actually notice that it's any different visually. This August sees two full moons, with the moon being full again on the 31st. The second full moon is also a supermoon, and being the second full moon of the month, it's referred to as a blue moon. I'm sure you're familiar with the phrase, once in a blue moon. Well, blue moons are not actually blue, but the phrase was first used in the 1500s, and it refers to something that happens extremely rarely. So, two full moons in a month is rare, so it's once in a blue moon. Moving to the planets, August of 2023 sees just Mercury and Mars in the evening skies as darkness falls at the start of the month. Mercury makes a decent evening apparition as it reaches its greatest elongation from the Sun on August 10th, when it will be about 4 degrees above the western horizon, about 30 to 45 minutes after sunset. Using binoculars will help you pick out the innermost planet from the twilight glow. Mercury is glowing at magnitude 0.5, so binoculars or a telescope will likely be needed to spot Mercury before it sets. Venus has moved from the evening skies and is in conjunction with the Sun, only becoming visible at the end of the month, when it will be very low in the east just before sunrise. Venus is shining brightly at magnitude minus 4.3 and will show a crescent that's about 11% illuminated. If you're an early riser with a low eastern horizon, this should look amazing in a telescope or even in binoculars, although a telescope will give a better view. Mars is still visible after sunset, but it is fading quickly. Mars continues dimming and appears smaller each day. Try using binoculars to pick Mars out about 45 minutes after sunset. Mars is fainter than Mercury, shining at magnitude 1.7, and it's small, at just about 4 arcseconds in diameter. By the middle of the month, Mars will be lost in the twilight glow, so get your Mars fix now. Fortunately, over the next year, Mars will begin to improve as it makes its way toward opposition in 2024. On August 18th, the 2.3-day-old crescent moon will be just 1 degree above and to the right of Mars. But you'll need an excellent western horizon, and using binoculars will help you to pick it out. At the start of August, Jupiter rises just after midnight. Your best views of Jupiter will occur around 3 to 4 hours after it rises. At the end of the month, the largest planet in our solar system rises at around 10:15 in the evening. On August 8th, the 22-day-old waning gibbous moon will be just less than 2 degrees above and slightly to the left of Jupiter. This will be stunning in a telescope at low power or with binoculars. Even the naked eye view should be a treat. Jupiter spends all month long in the constellation Aries. It begins August shining at magnitude minus 2.35, and by the end of the month it will be even brighter at magnitude minus 2.6. The planet begins the month spanning about 40 arcseconds, and by the end of August it will appear to have grown to about 44 arcseconds. Saturn is the showstopper this month when it comes to the planets. Saturn spends all of August in Aquarius and reaches opposition on August 27th. When a superior planet reaches opposition, it rises when the sun sets and sets when the sun rises, making the planet visible all night long. At opposition, Saturn will be shining at magnitude 0.43, and the disk of the planet will span about 19 arcseconds, while the rings span around 44 arcseconds. Saturn is easy to spot in Aquarius as the bright yellowish quote-unquote star in Aquarius. On August 3rd, the 16.5-day-old waning gibbous moon will be about 4 degrees away from Saturn. On August 31st, the full moon will be about 7 degrees away from Saturn. Using binoculars, you can just make out the rings of Saturn, but they look best in a telescope. If you've been watching Saturn for a while, you'll notice that its rings are becoming more on edge. As Saturn makes its way around the Sun, we see it from a different perspective. The last time that Saturn's rings were at their greatest tilt was 2018. However, by March of 2025, the rings will appear on edge, and for a couple of weeks, they'll actually be tough to spot. But they'll be wide open again by May of 2032. Uranus is in Aries all month and can be found about halfway between Jupiter and the Pleiades. Under the darkest of skies, you might be able to spot Uranus as a faint greenish-blue star. Binoculars will help you find it, and using a telescope, you might be able to make out the bluish-green disk of the planet. Uranus shines at magnitude 5.8 and spans just less than 4 arcseconds across. Faint Neptune spends all month in Pisces. You'll need a good finder chart and binoculars at a minimum to spot it. It makes a sort of flat triangle with the stars 20 and 24 at Pisces, which can be helpful in locating it. Neptune glows dimly at magnitude 7.25 and only spans about 2.5 arcseconds across, so you'll need really good seeing and higher magnification to spot the bluish disk of this cold and distant world. The night of August 12th into the morning of August 13th will see the peak of the annual Perseid meteor showers. Fortunately, the waning crescent moon, which rises at around 2 a.m. on the 13th, won't interfere too much with the Perseids. This shower usually produces between 60 to 100 meteors per hour, making it the best annual shower for observers in the northern hemisphere. The shower takes place when nights are usually comfortable, and the radiant of the shower is well placed in the northeastern skies. However, to spot the most meteors, you're better off looking 30 to 40 degrees away from the radiant. Scanning the skies from the zenith, or the point directly overhead, to the shower's radiant should be your best bet. Dress warmly in layers, have some water or coffee with you, and make sure you have a comfortable chair or a blanket to watch from. You can try to photograph meteors by getting a really good focus on a bright star. Then, stopping your lens down by one stop. With your camera on a tripod, open the shutter for anywhere from 10 seconds to 10 minutes. I recommend testing what settings work best before going out in the field to do this. You'll want a wide field lens. Around 50 millimeters or less will be best. Star trails are okay with meteors, but if you have a tracking mount, that works great too. Send us your best Perseid meteor image, and we'll feature the best ones in a future episode. Moving outward from our solar system, let's examine several deep sky objects that are seen in the plane of the Milky Way on August evenings. All of the objects that we'll explore this month are easy targets in binoculars or a telescope at low power. Most are bright, some even naked eye, but as with any deep sky object, being under dark skies and being far away from artificial light and letting your eyes fully adapt to the dark will always help when looking for DSOs. Our first object is the southernmost object that we'll explore this month, and it's also the southernmost Messier object. So let's begin with M7, also known as Ptolemy's cluster in Scorpius. This open cluster is bright, glowing at magnitude 3.3 and spanning nearly 1.5 degrees in size. The cluster is comprised of about 80 stars spread across an area nearly 3 times the size of the full moon. M7 lies about 980 light-years away from us. While it's visible to the naked eye, it is best seen in binoculars. To locate M7, start at Caus Australis in Sagittarius. This is the star that makes up the lower right part of the Teapot asterism. Once at Caus Australis, sweep 7 degrees west and you'll see the cluster. Our next object is the faintest one that we'll explore this month. I'm referring to the globular cluster M54. This cluster glows at magnitude 7.7 and spans 12 arc-minutes in diameter. Despite its magnitude, this is a difficult cluster to resolve, but even with binoculars, you can spot it as a round glow, brighter in the center. This cluster is interesting, as it's not a member of our Milky Way galaxy, but it is actually orbiting Sagittarius A, one of the satellite galaxies of the Milky Way. Lying at a distance of 87,000 light-years away from us, M54 spans about 156 light-years in diameter. To locate M54, start at the second magnitude star Nunkai, which is the star that represents the top left star of the handle of the teapot. From Nunkai, sweep about 4 degrees due south, and you should see M54. Our next object is absolutely one of the finest objects in the sky for southern hemisphere observers. For those of us in the northern hemisphere, however, M22 doesn't get very high in the sky. In fact, it never gets higher than about 25 degrees for observers at 40 degrees north latitude. But it's still worth a look. M22 is a magnificent globular cluster that glows at magnitude 5.5 and spans 32 arc-minutes across, making it larger than the full moon. If you're in a very dark location, you might be able to spot M22 with the naked eye as a fuzzy patch. In binoculars, the cluster appears as a faint cotton ball standing out against the background. The cluster's brightest stars are around 11th magnitude, so you'll need large binoculars or a telescope to begin to resolve the cluster. M22 is located about 11,000 light-years away from us and spans about 50 light-years across. Locating M22 is easy. Start at the Teapot asterism in Sagittarius and locate Caus Borealis, the star that represents the top of the teapot. From there, sweep 2 degrees east and 1.5 degrees north and you'll locate the cluster. Our next object is the famous Lagoon Nebula, or M8. This large emission nebula is one of only 2 star-forming regions that can be seen with the unaided eye for observers in the northern hemisphere. The other one is the Orion Nebula. M8 shines brightly at magnitude 4.6, but its light is spread out over an area 1.5 by 0.5 degree. But under the right conditions, it can be seen with the naked eye. In binoculars, you can see the bright inner portions of the nebula and dozens of stars within it. In a telescope at low power, you'll begin to see lots of details. I know several people who were able to see faint colors in the nebula with a 24-inch telescope from dark skies. So while it's rare to see color with just the eye, it is possible under the right conditions. M8 is located about 4,100 light-years from us and spans about 110 by 40 light-years in size. To locate the Lagoon Nebula, use the Teapot asterism again. From Al Nasal, the star at the western edge of the spout of the teapot, sweep north for 6 degrees and you should see the nebula. If you sweep 1.5 degrees further north, it will bring you to our next 2 objects that easily fit in the same low-power field. I'm referring to M20 and M21. M20 is the famous Trifid Nebula, which in photographs shows red emission nebula and blue reflection nebula. Half a degree northwest of the Trifid is the open cluster M21. Let's go back to the Trifid Nebula. With a telescope, you should be able to spot the dark nebulae within it, forming a propeller-like shape that gives the nebula its name. M20 is about 4,100 light-years away from us, and is about 21 light-years across. The nebula glows at magnitude 6.1 and spans 28 arc-minutes in size. M21 is a bit closer, at only 3,930 light-years from us. The cluster glows at magnitude 6.5 and spans about 14 arc-minutes. Several of its member stars are easily seen in binoculars. If you haven't realized it yet, this area of the sky is packed with DSOs, as it's right in the heart of the Milky Way. A bit higher in the sky is our next target, M17, the Swan or the Omega Nebula. I've always found this nebula to be bright and easy to spot with binoculars. Listed at magnitude 6, M17 spans about 11 arc-minutes in size, and the brighter portions of the nebula are easy to spot. Located between 5,000 and 6,000 light-years from us, the nebula spans about 11 light-years across. To find M17, go back to Caus Borealis and sweep 9 degrees north and 1.5 degrees west, and you'll see the Omega. Our next object is M16, located just 2 degrees north of M17. M16 is commonly known as the Eagle Nebula, and it is the home of the most famous image taken by the Hubble Space Telescope, the Pillars of Creation. Not long ago, the James Webb Space Telescope took an image of the Pillars of Creation, and wow! It is incredible what that instrument can do. M16 is another emission nebula that glows at magnitude 6.4 and spans 70 by 50 arc-minutes. It's located about 5,700 light-years away, and the nebula itself spans about 70 by 55 light-years in size. In binoculars, you can see a faint glow surrounding several field stars. Try using averted vision, where you look away from the center of the field. This allows the more sensitive cells in your eye to see the image. With some practice, you can see lots of details in this stunning nebula that will likely become one of your summer favorites. Our last object that we'll explore this month is the famous Wild Duck Cluster, cataloged as M11. Shining at magnitude 5.5 and spanning 22 arc-minutes, you can spot M11 with the naked eye under very dark skies. This is one of the most densely packed open clusters in the sky, and it's easy to spot in binoculars from suburban areas while holding up well to moderate magnification with a telescope. M11 lies 6,120 light-years away from us. It spans about 95 light-years across and contains around 870 stars that are brighter than magnitude 16.5. Locating M11 is easy as well. About halfway between the top of the teapot and Altair, the bright star in the summer triangle in Aquila, you'll see several 3rd, 4th, and 5th magnitude stars that resemble a fishhook in shape. The star that represents the bottom of the hook is magnitude 3.4 Altalemon Prior. From there, you can sweep southwest about 1.5 degrees to 4th magnitude Iota Aquilae, then sweep another degree west to Eta Scuti. Now follow that same path another 1.5 degrees and you'll spot the cluster just south of the center of your field of view. I do hope that you'll go out and find and enjoy these objects and that they become favorites of yours as well. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the AstroGuy Podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the AstroGuy Podcast, for past episodes and other surprises. Please subscribe. It really helps. Please consider leaving us a review on your podcast platform. This also helps us get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem. Seize the night. I'm Wayne Zool, and this was the AstroGuy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.